Hello and welcome back to Mikebaba-CATIA. We're kicking off Module 12 today by diving into the crucial Reference Elements toolbar. We start with the Point tool, a fundamental skill for any advanced designer. Let's get modeling.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate. Every line precise and true. Colors bright and brand new. Transforming steel into art.
Hello and welcome back to my channel. We're kicking off Module 13 today by diving into the crucial Reference Elements toolbar. We start with the Point tool. It is a fundamental skill for any advanced designer. Let's get modeling. So far, we've talked about various 3D modeling tools in the Sketch-based feature toolbar. With this toolbar and tools in it, we make 3D parts. Like to the Sketcher environment, after making 3D parts, we need to modify them. We do this with the other tools. But first, you need to get familiar with the tools in the Reference Elements toolbar. You have already become somewhat familiar with the Plane tool. This toolbar has 3 different tools. With them, we can create points, lines, or planes in a space. Note that a plane can be a part of the space. The first tool in this toolbar is called Point. With this tool, we can create a point in 3D space in 7 different ways. I click on this tool to activate it. The point definition window opens. This window has 2 sections. The first section relates to the method of creating the point. At the top of this section, you see point type. There is a framework in front of it. A V symbol is placed on the right side of this framework. If you click on this symbol, a drop-down menu opens. The different methods for creating a point are listed in this menu. The default method is coordinates. Below it, you see 3 frameworks. The name of the coordinate axis is mentioned in front of each box. Right now, the number 0 is written inside all 3 boxes. If you look at the coordinate center now, you can see that the software shows this point in green. Look at the second section of the definition window, which is named Reference. The first option is point. There is an option in front of it that is currently blue. The text default origin is written inside it. This means that the origin point of the coordinates is selected by default. Below this option, you see Access System. In the framework in front of it, you see Default Absolute written. This means that the coordinate system used is the main axis. Remember, defining your own axis system and selecting it here can simplify coordinate entry when working on complex rotated parts. Is it also possible to use other coordinate axes? The answer is yes. We can have as many different coordinate axes as we want. At the bottom, you also see a button. The button is labeled Compass Location. This means that wherever we place the compass, we can consider it as the coordinate axis. It is not useful for us right now. I click on OK with this setting. You see that a point was created at the center of the coordinates. The name of the point is recorded in the design tree. I activate the point command again. This time I write the number 30 in the X box, 20 in the Y box, and 20 in the Z box. I press the Tab key on the keyboard to move from one box to another. Look, a point is shown in a space. The dimensions we enter are also shown. I want to change the number 30 in the box in front of the X to -30. I double-click inside the box and type -30. I click on OK. It is seen that the point is placed in the upper right quadrant. Pay attention to the main axis in the bottom right corner. The positive direction of the axis is the direction where you see the letter of that axis. If you remember, I gave a negative value for X. We have created 2 points in a space so far. I want to create a point between them. I activate the point command again. I click on the V symbol in the point type section. I select the last option, between, from the open menu. Now 4 other frameworks were created. These boxes and options change according to our point creation method. I will click on the existing first and second points in the first and second boxes. Now the first framework is active. I click on the first point that was created at the center of the coordinates. The software marks it with a red color. Now the second framework became active. I click on the second point. The software also shows the second point in red. The names of these 2 points are recorded in these boxes. The third framework, which is ratio, became active. The number inside this box is 0 now. This number is the ratio of the distance from the first point to the second point. If we consider this 0 value, the software creates a point exactly on the first selected point. I press the OK button. Look, if I go over point 3 in the design tree until it turns orange, it shows the point at the center of the coordinates. I double-click on point 3 in the design tree to open its settings window. Now I can change the ratio value to 1. If I give 1, the created point will fall on the second point. Based on the numerical value I give, the created point will be variable between the 2 points according to that ratio. If I give 0.5, a point is created exactly in the middle of 2 points. Or more simply, I can click on the middle point button. The software automatically places a point in the middle of the 2 selected points by considering a ratio of 0.5. Look, the number 0.5 is written in the framework next to ratio. The support option is also useful when we already have a plane. In this case, by defining it to the software, the created point will be projected onto it. I click on OK. The point was created. To create a point using other methods, we need a 3D volume. Suppose we have a volume like this. I click on the point command. I set the point type to on-curve. The setting window has changed to suit the punctuation type. In the upper framework, which has curve written in front of it, we must select our curve. Note, I don't necessarily have to define a curve. I can also define a line. I click on the top corner line of my object. The software considers one side of this curve as the origin for measuring the distance. This origin is indicated by a small green square. The location of the point placement is also indicated by a blue square. In the second section, named Distance to Reference, we have 3 points. The first option, which is active, is called distance on curve. With this option, the measurement is done on the selected curve itself. If we activate the second option, which is named distance along direction, we must define a specific direction to the software. Look, when I activate this option, the settings window changes again. Now another option named direction appears. The framework in front of it is blue and waiting for a direction to be defined. In this mode, the measurement is done along the defined direction. Note that you can define just any direction. For example, if I click on one of the vertical lines of my volume, an error will appear. I click on Cancel. I go to the sketcher environment with the top surface of my volume. I draw a line in a specific direction. I return to the part environment. I click on the point command. I set the point placement to on curve. I activate the second option, distance along direction. I click on the line in the direction framework. I start increasing the number in the offset box using the black arrows. Pay attention to the blue square and the dimension next to it. You can see that the square moves and our dimension shifts in the direction of the line we define as the axis. Now look, the offset is 40. I click on OK. I activate the measure tool. I measure the distance between the start point and the created point. You can see that it shows the number 48.074. The third option is ratio of curve length. When I activate this option, you see that a framework name ratio opens below it. I can write a number from 0 to 1 in this box. With this framework active, the software first measures the length of the curve. Then it creates the point based on the ratio we specified. I press the Cancel button. I click on the point command again. I activate the on-curve state. I click on the arc of my volume. Look, in the two options, distance on curve and ratio on curve length, two options appear, Geodesic and Euclidean. These two states are two different methods of measurement or dimensioning. When Geodesic is active, the measurement is taken on the curve itself. When Euclidean is active, the measurement is taken as the chord length of the curve. The software indicates the geodesic mode with a capital letter G. Pay attention to the letter G after the dimension. That wraps up this module. If mastering these methods help you, please give this video a like. Don't forget to practice and subscribe to Mikebaba-CATIA for the next lesson on advanced point creation. See you next time.
Let's build a